Good afternoon, everyone. How are you doing today? I hope you can hear me. Let's all start to join the class. So we'll be proceeding with our lecture in just 2-3 minutes. Please tell your friends to also join the class as we've started the training. So as you all start to join the class, let's start to introduce ourselves using the chat section or maybe in the Telegram. So let's start answering 3 questions. Which country are you from? Are you from Ethiopia? Are you from Ghana? Are you from South Africa? Please go ahead and say in the comment section, and also what is your expectation from this training. You just put it in few words. So until we start, let me introduce myself. I'm Lidatu Taddasa. I'm a professional in electrical engineering and also software engineering. I've been teaching a lot of students, thousands of students around the world in embedded systems and software development for a couple of years. And here we are, I'm also teaching you. So please go ahead and say your name, your profession, and where you're from. Also, you can write your expectation if you like to. So most importantly, write down your name, which country are you from, and what is your profession. So we have Aldana, and I couldn't name it, but I am showing you in the screen, from Ethiopia. Welcome. And also we have, okay, can you remove the background music? Okay. Okay, I think you can hear me better now. The background music should be gone. Francis from Kenya is also taking part in this training. We're very happy to have you, Francis, with us today. And we have Hailab Mulugeta from Ethiopia. I'd also appreciate for you guys to mention your profession, which profession are you currently working on, or if you're a student, what are you learning? That could also be important or happy to know about that part of you. And we also have Nathnael from Ethiopia, Amhara region. It's quite interesting because we have a lot of students from Ethiopia, also different parts of Ethiopia. Francis is expecting to learn a lot today. That's interesting. We will give you all we have. So hi, my name is Adana from Debre Tabor University. So we have students from Debre Tabor, we have students from Addis Ababa and different places. And Meron from Ethiopia, and a computer science student. That's interesting. Someone say, can you please check camera? Are you saying my camera, or I don't know what you meant. Can you please explain? Because is my camera good? So it's good from the technical side of the team. Maybe if you're having a lot of blurry vision, that could be your connection or internet. Please go ahead and check. I hope you can listen to my voice well. Is my voice well? So that's also, I got a confirmation on that also. So yeah. We have from Ethiopia, Faris. a programmer and a mechanical engineering student. We have a lot of you who have joined us online today. I'm going to have to jump a bit to say few of you. So my name is Absalat and I'm from Ethiopia, grade 11 natural science student. So we have great high schoolers, also university students, also different parts of Africa and Ethiopia. It's quite fascinating. Also, Kantha Mikhail, 16 years old, high schooler. Welcome, welcome everyone. I'm really happy to have you all. Eldana Abel from Ethiopia, computer engineer. I expect to fluently manipulate Arduino IDE. You would definitely do that. Okay, so students are joining in. So let's use our time effectively as we have passed 16 minutes and we need to be using our time very effectively for all the remaining days so that uh, we don't miss a bit and we can teach you well. So for the starting point, what we usually do is we send out a baseline survey. So a baseline survey is something that we use to understand your status before the start of the training. So what is your status in programming, in Arduino, in electronics, and a couple of those questions. So please go ahead and start to fill out the form and start to fill out the form and once everyone fills it out, we're going to proceed. So every form that is being sent out in this group is counted as an attendance. So make sure that you fill it in. Some of the forms that we send out uh, are not being used for any grading activity. For example, this baseline survey won't be graded, but necessarily we would consider it as an attendance. So, it's mandatory that you have 100% attendance for you to get certified. So please go ahead and start filling in these baseline survey. Someone said in the Telegram section, uh, is the YouTube video being recorded? Yes, of course, it's being recorded, and you can always come back to our YouTube channel and start to learn also from there. So as you guys start to fill in the form, um, let me ask you guys. Okay, so I can see that from the data given to us by YouTube, um, most of you who are actually taking part in this training are still not subscribed. So I would really appreciate it if you go ahead and subscribe to our YouTube channel. That would really support us, and also we keep on doing this for a greater, better community. And you can always share the trainings that we provide for free and also paid version of it. So please go ahead and start filling in the baseline survey. Okay, so for those of you who have just joined, good afternoon, good morning, or good evening, depending on the part of the world that you're actually joining us. So what we're doing at the moment is we're filling in a baseline survey. This survey would be used to understand your status before the training, and we're going to do this one more time at the end of the training so that we always improve the trainings on what we have changed and supported you. So please go ahead and fill out this form. It's not something that is graded, but necessarily every form that you fill in would be counted as an attendance. And attendance is 100% mandatory for you to get a certification. If you have a challenge of internet or if you have a challenge of power, when you lose that in the Telegram group, send me personally. Send me personally that you have lost the internet, and when you come back, say I have got the internet is back, the power is back. Or also you can send us an email at innovatechnologies.com at innova 19 at gmail.com. So we can also do that, but sending me a telegram, a direct message would be much better. So please go ahead and start filling out the form. And for those of you who have filled in the form, please say in the chat section, also in the telegram group, which country are you from, what's your name, and what's your profession. We'd really appreciate to know about that. Barakat said, where can we find the form? The form, I have sent it in the chat in the YouTube and also in the Telegram. Okay, please go ahead and check out the Telegram group. Barakat, I think this is you. Yeah. Are you have you joined our Telegram group? Because it's important that every single one of you join our Telegram group. In case if you haven't, we can send out the handle of the Telegram group here, which every part of the training would be provided, exams and everything would be through that. Our main communication channel is through that. So please go ahead and start join the Telegram group, and also make sure to fill in the baseline survey. Okay, so we have Hisnul. If I'm sure, I'm sorry if I'm saying your name incorrectly, or I can say by father's name, Muhammad, from Ethiopia, Addis Ababa. He's a high school student in BNA. What's BNA? I'd really appreciate if you can expand the abbreviation. Also another person from Ethiopia, Firdaus Hailu. We're happy to have you all. So we should start our training at the moment. So those of you who haven't completed filling in the baseline survey, please go ahead and fill out the baseline survey. Okay. So in that case, let's go ahead and start the training. Okay, So the training would be following with the first of, would start with the evolution of computers and digital systems, what they actually are, and would start to discuss about Arduinos today. And tomorrow would start doing projects, and projects through projects, you'd be developing your skills. And ultimately, at the end of the training, you would be you'd be doing one project that is um, um, so you'd be doing one project which you'd have it as a portfolio for your development. So we'd team you up into groups and you start to do that project. So we'd be sending you a grouping form towards the end of this training. All right. So we'll be discussing about the evolution of computers, digital systems, Arduino, and FPGAs. So let's start off with the evolution of computers. But before we go on, I would like to ask a question. What are transistors? So please go ahead and write in the chat section or in the Telegram group uh, about transistors. What do you know about transistors? What are transistors? So I would like to listen what you know about transistors. What are transistors? You can write it in the Telegram group, also in the chat section, so that I can read from. So Eldana, I think that's Eldana, are active electronic devices that are made from semiconductors. Yeah, precisely. I would like to listen to one person say a bit about this, and then we're going to proceed. Another person said a transistor is a very small electronic component that can control electrical current, precisely. And also, you said semiconductor device for amplifying current, voltage, or for switching. Precisely. So these are the importance of it. But let's come back to transistors after the history part. So how did we actually landed up in a tremendous amount of computation today? So before this, there was a lot of efforts towards computation, and the first automatic calculator was known as the Babbage engine. So the Babbage engine wouldn't have done anything sophisticated in mathematics, but it used to do polynomial equations and everything. So it got 25,000 mechanical parts. This is completely mechanical computer. There is no part of it that is actually electrical. So it weighs 10,000 pounds. So this device weighs 10,000 pounds and costs 17,000 or close to 18,000 euros, and which it was built in 1834. So let's check out the video. You can also research more about the Babbage engine. So let me. I hope you can listen to the voice. I get it. So I was speaking, but you guys couldn't listen. But maybe we can. I can explain more on the next video. So this is the Babbage engine, and you saw how it actually operates. Maybe let's see another video of it, um, of the Babbage engine in action. So you can see that there's a lot of mechanical actions that are going on until it actually produces some result. And this is maths. Can you believe it? It's so fascinating. So people are so curious to improve computation. It was never the way it was previously. Okay, so you can see that it doesn't do anything much above polynomial equations, but this was how computation was done back in the day. And you can see that thousands and thousands moving parts are moving to make simple calculations. So people were very curious to automate um, the process of computation. These weren't so effective. So the next were relays, the mechanical relays, which were invented in the 1835. So these relays are a bit different than the previous ones because they include both mechanical and electrical part. So the electrical part is something that actuates or turns on and off the mechanical part based on the signal that it have electrically. So now, from purely mechanical Babbage engine, things start to change into something electrical. So this was Z1, which was in Germany around 1938. And due to the Second World War, it was destroyed and it was reproduced. So this is also the other computer that was done, but necessarily it wasn't much of a computation that it can do beyond the calculators that we had. So just for the sake of curiosity, let me show you one video. So the Z1 computer was done by a very first computer scientist, Conrad Zuse, and it's still in Germany, in Berlin, Berlin Museum, which still visit. So, you know, what I really admire is the curiosity of the humans always to find a better way for computation. So this Z1 was a bit different than the Babbage engine because it has arithmetic unit where calculations are done. There is a memory unit and there is an input-output unit, and we have a punched tape. So what it means by a punched tape is you have for every program that you run, you have a different tape. Uh, in this era of computing, we don't really use different computers for different function. For listening music, we don't use another computer. For studying a book, reading a book, we don't use another computer. We all use the same computer for all our purposes. So in the previous days, it wasn't actually the same. So we use punched tape for every specific purpose. And it's not the case that we use the punched tape in the same device, like different punched tapes in the same device. Using that won't be the case. but every punch tape requires a different machine, which was very difficult and quite expensive. And then came the innovation of the vacuum tubes. So the vacuum tubes are now completely electrical. So, which means you have the power of switching, turning on and off with only electrical signals. Previously, during the Babbage engine, it was completely mechanical, and then in the relays, it was mechanical and slightly also electrical. But later, it changed into completely electrical, the vacuum tubes. So these were one of the pioneering movement where things started to change, where scientists are using the vacuum tubes to actually control the electrical signals, count numbers, and do arithmetic operations. But then came a challenge of a lot of wires. So imagine, for example, there is a machine, and that machine probably has 1,000 wires that is going around it. And if you try to pinpoint each device and connect it through point to point wiring, then it's going to be very difficult to trace between the 1,000 wires, which is faulty, which is correct, and also there is a heat that is raising up. And that was the severe challenge. But then significant improvement in technology started to happen, even using the point to point wiring that you see here. But necessarily, this wasn't enough for any of the calculations or the things that are being done in computation. Then came the first general purpose computers. So the first general computers is quite funny when you consider where computers are at the moment and the processing power that we had. So this computer was not very advanced from some of the calculators that we have right now. It's way less than any ordinary phone in the calculations that it does, but it was something amazing device back then. It has uh, uh, 18,000 vacuum tubes. So vacuum tubes resemble the incandescent lamp. So the lamp that heats up when you actually turn it on. So this device was extremely humongous. It it uses a space of 1,500 square foot, which is 1,500 square foot area, which is, I mean, part of football. I mean, significant part of a football field, half of a football field maybe, and it's 3 meters high. uh, it fills up the whole room. And you can imagine the weight is 30 tons. And when this computer actually turns on, the city loses power because it, it consumes powers in megawatts. And it was very difficult to cope up with this because reliability was an issue. When a certain part of the ENIAC's computation fails, then what usually it's done is you figure out which vacuum tube is actually burnt out. And there wasn't any smart way to do this. And all the scientists, all they do is manually they start to figure out which one is actually not working, and they go between each vacuum tubes to find out the faulty ones. If they are lucky, they could find it within one try, but if they are unlucky, necessarily they have to go between 17,999 vacuum tubes before they find the faulty one. So let's see how it actually looks like in this. It's still found in the University of Pennsylvania. So they had, I mean, great computation, and it's where most of uh, the new breakouts are happening in America. So mathematicians back then have done this. computer science, mathematics. You can see that each vacuum tubes are there sitting there, and imagine how the plug is humongous. This is the ENIAC. It's a room full of general purpose. So you can check out a lot about these researches in YouTube. So what it means by ENIAC is electronic computer and integrate. Um, so you can see how humongous plug in history as it was one of the biggest computation devices. The ENIAC was very famous due to the fact that it was used for actually innovation started for the fire table. Fire table is something that the soldiers use for firing long range firearms. There is a lot of calculations that comes along with it. So it was meant to be used for that, but necessarily it wasn't successful until the World War II has ended. So it came out to be it was realized after World War II. So now we can start to discuss about transistors, which you guys have started explaining a bit about it in few minutes ago. So this was the challenge that actually ignited the innovation of the transistors. So transistors were innovated in the Bell's lab, where scientists known as John Barden, Walter, and William Shockley, they have innovated this. Transistors, in a specifically English word, what it means is it's a transfer of resistance. You can see that here, transistors. So it's a transfer of resistance. So this can be used. I won't go deep in any of the physics or the engineering of it. We'd only focus on the application. So what a transistor actually does is you can use it to amplify voltage, current, and also you can use it as operational amplifiers. But necessarily, most important character about transistors that you should know is it's a switch. It's a switch. All the scientists who have been struggling with relays, mechanical components, and everything to find a switching device so that we have zeros and ones. If you have the power of zeros and ones, then that's fabulous, where you can start to do a lot of things like calculations, because you can represent numbers using binary numbers. So if you can represent them in binary, then a lot of the mathematics and computation can be done. So what happens in transistor, very specifically speaking, is this is the base, and we have whenever we have a voltage, depending on the type of the transistor, let's say 3 voltage. So when 3 volt comes in through here, then it's going to be closed circuit, or else it's going to be open circuit when there is no voltage coming in. So this way we have on and off signals, which resembles 0 and 1. And starting off from that, we can be able to build anything that we want. So there are a lot of transistors that we have around the world. There are three legs for a transistor, is most importantly. So we have the base, we have the collector, and the emitter. So all you have to know is about these three and how the connection is done. So we can use it in our Arduino projects for switching purposes. And transistors could be in different types, but fundamentally they are classified into two based on the nature of them. This one is known as the through-hole transistor, and this one is known as the surface-mounted transistors. So the surface-mounted transistors don't go through the PCB or the printed circuit board, which we are going to discuss it in a bit. So transistors differ based on the amount of voltage that passes through them or the amount of current that passes through them. And also for the purpose that we use them. Maybe is it for just switching LEDs, or are you using them to switch 200 volts, or are you using them to switch 1000 volts? Based on that, their specific characteristics really differs. But the fundamental working principle is the same. It accepts a signal and then it turns on or it turns off. So now that's a true success. Computers can be now carried with, trucks. It could be funny for you when you see computers at the palm of your hands, but necessarily this is how it was. Now, due to this transistor innovation, computers can be owned by labs. Before that, the only way that you can own a computer is as a country. Now you can have it as a lab, and it costs few thousand or few 10,000 euros or dollars. So let's discuss about printed circuit boards, which are very important when it comes to embedded systems. So printed circuit boards are a way that you can connect your specific devices so that it's in a very compressed and easy to debug manner. So every space that you see, for example, this one is a space for one of the IC that we're going to put, and maybe this is for one of the resistors, and this is for one of the transistor, maybe not a transistor, but a capacitor or anything else. So each point is a place where you're going to put your device. And the paths that you see, the green paths that you see, are copper wires. Necessarily what it means is I am splicing one of the leg of this device, maybe if it's a transistor, to the resistors. In the early days, as I showed you earlier, it was point-to-point wiring. You can see that one point is physically wired through a wire to the other point of the leg. Okay, these device legs are point-to-point wired, which was very difficult to handle defects, or maybe even to put a lot of wires together. That was very difficult. That's why the printed circuit board makes a lot of easy life for the engineers. So you can see that all these green things that you see is actually a copper wire that runs the electrons. So you can connect this leg with another leg, and you can see probably hundreds of wire here, but necessarily it doesn't occupy a lot of space, and it's quite easy to find which one is not actually really connected, and then we don't have a hit. If you are really wondering why these all the circuits are not straight, but they're bent, they're all bent 45 degrees or something closer. To explain this, I'm going to use a very simple example. So you're running in a corner of a building, which is going to turn 90 degrees. So let's say you're running straight forward through the corridor of the building very fast at a speed of electron. That's 3 times 10 raised to 8, I believe. Or that's something closer to a speed of light, but electrons and speed of light are very close enough. So you're running at 1000 kilometers per hour, and then right at the edge of the corridor, you would like to turn 90 degrees. What's going to happen is very unlikely that you're going to turn 90 degrees. You're going to smash yourself to the wall. This is true for electrons. As electrons are speeding up with extreme speeds, and you give them a 90-degree bend of wire, then these edges of the wire are going to get very hot, very in few seconds, and that is going to cause a defect. So when it's a bit 45 degrees, the flow of electrons is much better, avoiding collision. So this is a very vivid or layman's electronic explanation, but this is the basic concept that we have, all the wires getting bent in a PCB or a printed circuit board. So now that we have a printed circuit boards, we could have hundreds of components in our printed circuit board. But necessarily there still remains a challenge. The challenge is that we don't have enough boards to put a lot of components. So then came the integrated circuits. So what it means by integrated circuit is, very easily explaining it is, integrated circuits, inside of it, they actually have a lot of components inside of them, which means the transistors, there is a printed circuit board inside of the IC or the integrated circuit. Now that gives us a power of putting a lot of components inside of the integrated circuit board. As you can see, these, for example, are surface mounted, but when it's through hole, we have a hole through the board that we pass the devices, the electronic components. But when it's a printed circuit board, I'm sorry, if it's a surface mounted one, we just put at the surface of the circuit board, and then we just weld it. For example, these devices that you see, they are all on the surface of the board. That's why we call them a surface mounted ones, like the IC also. So now the IC could have hundreds of components, thousands and 10,000s, 100,000s, and millions of components inside of it. Now this bring a lot of computation power, which is much better than it used to be in the ENIAC. So in 1982, we had the first Intel 8286 chip, which is in a silicon gate CMOS processor of 1.5 micrometer. And the die size, or which means the whole size of the IC, is actually less than 100 centimeter. It's only 68.7 millimeter square. Necessarily, it's less than 1 centimeter square. I'm sorry. Previously, I've said it was 1,500 foot square that it took for the ENIAC, but it had 18,000 components. But this one now has 134,000 transistors inside of it. Now we have a clock speed or computation power of 6 to 12 clocks megahertz. So what this means, clock speed, is this is a frequency, which means it can do 12 million, because mega is million, 12 million calculations in just 1 second. You can imagine how computation grew. And in 2008, we had the Core i7 quad processor with 45 nanometer silicon gate CMOS processor. So what it means by silicon gate is the distance between the emitter and the distance between the collector. So as I've told you earlier about transistors, this is the collector or the emitter, and this is maybe the collector, and this is the emitter. So the distance between the two is known as the silicon gate. So it's 45 nanometers. You wouldn't be able to see it without a good microscope. And the clock speed raise up into 2.4 gigahertz, which is 2.4 giga calculations in just 1 second. And transistors on this die size of very small, we have 731 million transistors inside of this. The computation now started to grow and grow in 2015, and it keeps on growing. In 2015, we had 7 billion transistors in just a very small size processor, which can process 5.2 gigahertz of calculations in just 1 second. Now, this is a previous data, but on 2025, some of the researchers in China are able to put a couple of transistors, 30 transistors, in just a single virus. So it's quite amazing that you can see innovation have started to grow. This is a comparison between a human and an IC. So this is IBM ring oscillator, and this big stain that you see is a human hair, a single human hair under the microscope. You can see how small the IC is in comparison to the human hair, and it's extremely small, while it actually have 12 transistors inside of it and couple of capacitors. So now electronics industry is booming and booming even beyond the automation in this, the automotive and the steel industry, and we have a lot of technologies that are going on. So now system performance increased extremely because we have a very fast processing device, and cost per function also decreased, which means in the previous days, for every single function, we have one computer or one puncher tape. But now you buy a computer, you can play game with it, you can listen to music, you watch your movies, you can surf the internet, you can text with it, you can record your videos with it, you can do a lot of things with just one computer or one cell phone. So necessarily, I mean, cell phones are also computers because they compute. Yeah, that's it. That's pretty much it. So power per function decreased because these days you can charge up some computers that can stay for 30, 20 days, like military computers. And system is extremely reliable. You don't see your computer failing up in every other day. And that is the case that we have found due to the innovation of the transistors. Okay, I'm going to jump into digital electronics and then follow up on Arduinos. So before we do that, I would like to listen if you have a couple of questions regarding this, and then we can follow on. If you have questions, you can always ask in the Telegram section or also in the chat section. Let's have a couple of minutes for questions. I'd be answering the questions, and then we'd be jumping into our Arduino lectures. If you are clear, I'm going to proceed to the next section. Okay. So, don't see any questions in the chat section. So I'm going to proceed. All right. Okay, for digital electronics, we're going to come back to it tomorrow. But for today, I'm going to focus on explaining about Arduinos. For those of you who have just came in a bit later, please go ahead and fill in the baseline survey. The baseline survey would be used for us, internal purpose, and for you as an attendance. So every form that is going to be sent out in the group would be used for attendance. And it's mandatory that you have 100% attendance for you to get a certification. So please make sure to fill in the baseline survey because I see a couple of you haven't actually done that. And so the baseline survey would be used for us to understand how you are in the beginning of the training, and we're going to use it. We're going to send you the final survey at the end of the training so that we can understand the delta between that and how this training actually supported you. And we keep on improving and improving our training to support you more. So please go ahead and start filling in the baseline survey if you haven't filled it. And also join our channel because I see a lot of you haven't still subscribed to this. And we really appreciate to build up a big community in Ethiopia and Africa regarding STEM education. And for us to reach this, it's very important that we have your support in growing this. Okay. So there are a couple of questions. So would you please share the PowerPoint? PowerPoint is not actually shared, but we have a book regarding Arduino, which you can always buy, which have all the information that we're going to explain about this, since this one is a licensed under the company and it's not shareable. But you can always come back to the videos and start learning. Um, So someone else asked, I think that's no. How do storage units and calculation units work in electronics level? Can you give us some hint? Okay, I'm just going to explain in a very rough way. So in the electronics unit, I believe you understood that when the transistor is actually on, it means it's one when it's transferring current. When it's zero, which means the transistor is open circuit and there is no current passing through it. So we now have zeros and ones. So trying to store the zeros and ones uh, would make up the storage. Actually, let me connect some device and I could explain this better. There is a couple of things regarding the connection, the connecting wires for you to write it down on a whiteboard. So I'm going to explain it tomorrow, but for today, let me just roughly explain it. So the storage units, um, as I've said, using the transistors, when it's on, that's one, when it's off, that's zero. So you can start to translate any image using numbers. For example, blue has a number, red has a number, any color that you know has a number. So images are actually a combination of small color points. So storing each color point as a number and translating that into zeros and one, we can be able to store in our memory. So inside of a memory, each memory unit has a transistor, which means when that memory unit is actually on, then it's saving one. When it's off, then it's actually saving zero. That's the rough hint of it. We'd come back to this tomorrow, I'd remember, because I'm going to write a note to explain it to you better using my um, Wacom. Okay, now let's proceed into learning about Arduinos. Okay, so in this section we're going to learn about Arduinos, electronics, and we're going to practice a bit on this. Yeah. So before I start to explain about Arduinos, most of you came in to learn about Arduino, but I want to know if you are actually aware of what Arduino is. Please go ahead and start writing in the chat section what Arduino is and what you know about Arduino. Please just write it down from what you know. It's okay if you know it or you don't. Whatever you think, you can go ahead and write it down. Please write it down in the chat section what you know about Arduinos. I'd really appreciate to understand about this. What are Arduinos? Okay, Noha said a device that is used to integrate computers and sensors or stuff. That's very close. We can use it to integrate sensors, and the computer is actually the Arduino for our case. And Kadu said Arduino is a board that we can use to write a code on it, which helps us to control robot sensors and etc. That's correct. It's a microcontroller. Of course it is. It is a microcontroller. Uh, it's a small computer. Yes, we can say that. We can say that. Because necessarily a computer is something that computes, that adds, subtracts, multiplies, and everything else. And also in the Telegram section, someone said Arduino is previously programmed device and uses the software to interact with the device. It's not necessarily previously programmed. I don't know what you meant, but probably if you wanted to say we program it, then we use it to interact with the device, that's correct. Okay, so let me go ahead and start explaining about this. So Arduinos are open source devices. They're very easy to use, very much easy to connect and everything else. It's extremely easy for prototyping your ideas. It doesn't really matter if you are an electronics student, if you are a political science student, or if you are a social student. Anyone from different backgrounds can start to learn about Arduinos very easily. Arduinos give you the power of your imagination to come to reality. And the other important factor about this is it's open source. You know what open source means? That means you can necessarily rebrand it to your brand and you can even reproduce it. The software that comes with Arduino is open source. And also the hardware circuit connection is also open source, which makes it quite easy for you to start to manufacturing it even. And there is no strings attached that you wouldn't be sued because you manufactured it. So sometimes things that are open source necessarily are not free. Open source does not necessarily mean free. Things that are open source could also make you pay, but Arduino is free and open source. So there are various applications that comes along with Arduinos. Maybe let me show you some of it so that we can start to appreciate what you can be able to do. So at the end of this training, you're supposed to do a project regarding Arduinos. So it's important that you do this. So you see that in this Arduino application, there is LED light, which are being used as a screen. And also you can see here, it's being used for motor control or making watering your plant and everything else. And also you can build a quadcopter or a drone using Arduino. It's quite impressive that you can do also a 3D printer of your own, and you can find open source DIY regarding Arduinos, and you can make really anything else. Your imagination is the only limit to using Arduinos. So why is the fact that everyone in the world, from scientists, practitioners, students, and innovators are using Arduino? That's because it's quite easy, it's cheap, and it's cross-platform. And it's simple, clear programming environment, and it's open source free software and open source free hardware. So regarding this training, we won't be using hardware components, but if you'd like to have a hardware component on you, for your projects, or you want to buy Arduino kit, we sell this and we ship it to any part of the world that you're living in. So whether it's in Addis Ababa or Jimma or Redawa, we can ship it for you. The kit plus the book, so that our book have 15 projects that you can sit down, start to learn. It's very intuitive. We've written it, and we've almost close to 100 students have learned with our book, where they have mastered Arduino. So if you're looking to do this, go ahead and send me a text, or you can send an email to infnova19@gmail.com, and we'd ship it to any part of the world that you live, or any part of Ethiopia. Okay, so Arduino does have a couple of important components. We have a board, there's a module, shield, device, and others that we can also discuss. So Arduino, there are a lot of Arduino devices, but before that, let me check in to show you an Arduino project. There are a couple of projects that you can find in YouTube, but necessarily there is quite fascinating a lot of projects in Arduino. For example, this one is something very easy but very important. It tries to identify the trash that you throw, if it's wet or dry, and also this is LED chaser, which you can use it for different purposes. This is obstacle avoiding robots, like see left and right and move. And this is a revolution per minute calculator, how fast is your wheel revolving. And this is a solar panel project, the solar panel faces the light or the sun, so that you have maximum power. And this is a game that you can do it and start to play it at home, where you need to go between and this is for smart home projects, also laser security. Means whenever someone tries to pass, there is an exception signals that goes through the wire, or a water level sensing, where you can sense the water amount in your bunker to show alarms, or switch off the, or you can use this for card-based closing. Okay. Um, so this is an automatic clothes drying machine. Uh, there is a lot of things that you can do using Arduino. So this is RC car that is being made with Arduino. follows a line. So you can imagine in the streets, for example, we have a dice game. So it's a solar system. So this is generally an Arduino project that you can start to understand about Arduinos and what you can do with it. So let's start to explore the hardwares related to that. Okay, so there are a lot of Arduino boards that you can use based on your purpose. There is an Arduino Uno, which is the famous one. We have Arduino Zero, Arduino Espalaro, Arduino Nano, Arduino 33 BLE, which you can even implement AI and machine learning codes. And also we have Arduino Mega for bigger projects. There is a lot of them, and you need to choose it based on your specific demand. So my voice was unclear previously, but I think it's better now. Can you confirm if you can hear me better? Bethlehem said you're a bit unclear. Sorry, can you fix? I think it's fixed. Can you check on it now? Okay, thank you. Okay, so now we have the Arduino, then there are modules that come along with it. So there are a lot of modules that you can use using Arduino. That could be a Bluetooth module, a touch sensor module, that could be an ultrasonic sensor, or different things that you can attach to your Arduino and start programming to bring in data or to output a data. So modules in Arduino are tremendous amounts in the world. Necessarily anything that you think of, you can find it as a module so that you can connect it to your Arduino for any of your specific projects. So we are doing these kinds of training so that we can appreciate startups, and we can also appreciate anyone who would like to do DIY projects. So if you have a startup and you're trying to realize it, then this is a great course for you. So there is also shields. Shields are a bit different than modules because it has one specific functions, but also you can do a lot of things with one of that. For example, this is a LoRa shield, which is going to hold most of or all of the pins of the Arduino. You cannot connect any more sensors, so that the Arduino is going to be used for data logging and everything else, using the data logging, for example, from Adafruit. And then sometimes you can you can use multiple shields together. But when you use shields, then you are not able to use different modules than that specific shield. So you're going to use modules that the shield actually is capable of allowing it. So there are input devices or input modules, and we also have output modules or output shields. So input devices could be, for example, this is a sensor. This is a touch sensor that identifies the fingerprint. I mean, it's a fingerprint sensor, not a touch sensor. So it identifies the fingerprint, which you can use it for different purposes, for security reasons in your project. This is a temperature sensor, so you can connect it to your Arduino, and then you can sense this temperature and use it for any of your purposes. And this is an RFID sensor, which means you can use ID cards for validating payments or validating security protocols like opening doors or opening safes for different reasons. The application is your specific requirement, but then what it does is it identifies specific cards with specific program inside of them for access. And there are also output device, like for example, this is a speaker, but it's a bit different one, which is known as a piezo sensor, but it outputs sounds. So you can use this for outputting sound. This is a screen and this is a motor, so that these all are output sensors or actuators, as we like to call them in the engineering world, like the motor specifically. So it actually outputs a certain signal. Things would be much clearer as we start to do projects. So necessarily what you need to know about input and output is that input input devices input any type of data towards your Arduino, while the output device outputs any signal from the Arduino to the world. So if you're willing to use Arduino, if you maybe have Arduino, or you have Arduino, then you can download the Arduino software. Just go ahead and search on Google Arduino IDE, and then you can find it for any of your specific operating systems. This Arduino IDE software is written by Java and C++. So you can just search Arduino IDE, maybe add software download, and then you go to the first coming page. You can find that the new release is here. You just go ahead and pick your operating system. Necessarily their website would pick it for you automatically, and then you can go ahead and download and start to use it. That's pretty much it. But if you don't have Arduino, the physical device, it's okay. There's a perfect simulation for it. I'm going to get to that in just a few minutes. And if you'd like to use Arduino for this project, you can buy our kits. All you have to do is just text me, or also you can text Dave from the chat in the training group, and we can send it to your location wherever it is, in Addis Ababa or in any part of Ethiopia. We can also ship it in other part of the world, but I don't think you'd have it in just ready for your training because it's a bit late. Yep, that said, so for the Arduino IDE users, let me just go ahead and explain this. Then later I'm going to explain for the Tinkercad user. So if you are using Arduino, you have a couple of specific places that you're going to use. This is this place where you're going to navigate, and this is the name of the project. For example, this is Blink, and that's the name of the project. And this is the place where we are going to write the code. And finally, this is the place where outputs are going to be shown, like errors and everything else. So here, the most important thing if you're using the Arduino IDE is you need to press the right button. This is for you to compile the code, to check for errors about the code, but necessarily it only uploads the code to your Arduino if you do this one. If you don't do this one rightly, then it's never going to upload it to your Arduino. So for me to understand how many of you are using Arduino, you have the hardware device, please say it in the chat section, I have Arduino, or I don't have Arduino device. So let me understand how many of you have this, so that maybe tomorrow I'll reserve a couple of minutes so that I'll show you how to upload a code using actual Arduinos. So, okay, I don't have Said King. If any of you have Arduino device, let me know. So most of you don't have this Arduino. Okay, most of you don't have Arduino. Okay, I mean, if you want to buy, you can always buy. Maybe we can give you a discount for this week. because it's going to support your training. We're going to give you a promotion code. You can use that code until the end of the week to actually order some. I think my voice is it not audible, because Noha said my voice is not audible. Maybe my voice was not audible when turning on the videos. That could be the case. Okay, so I think almost all of you don't have Arduino devices. Um, we really appreciate that you get these devices. So we would put you a promotion code that you can find discounts for this week. Maybe also including free delivery in Addis Ababa. Okay, so the steps that you always shouldn't forget is you run the code, then you upload it. This is save and everything else. So let's pass this because this is not for most of you. I'm going to come back tomorrow if there is someone who says I have Arduinos. Okay, so I have a question. How much does it cost, the Arduino Uno R3 kit? Um, so the Uno R3 kit, which includes every device that you can work on our project, and also which is 15 projects that are included in the book. And also you can do couple of more things. So the Arduino plus the book, we sell it for 10,500 birr, but we're going to give you a discount plus free delivery if you're buying it this week. It's 10,500 birr. Okay, so let's discuss about voltage, current, parallel series circuits, discrete IC components, and some of it, so that you don't fry your Arduino after you've bought it. And then you use it, you don't burn out your Arduino. So what's the difference between voltage and current? Before I go on, I would like to listen from your side. What is the difference between voltage and current? What is the difference between those two things? So what we're doing now is starting off to understand what voltage and current is. So please go ahead and write down what is the difference between voltage and current. What is the difference between voltage and current? Okay, Bethlehem said what pushes electrons through a wire. I think that's voltage that you wanted to say. And while current is actual flow of the current. Good explanation. You're explaining it in loop. A current is what actually flows in a current. Okay. I would appreciate it a bit, Liam, if you could explain a bit more. Um, okay, voltage is what pushes electrons through the wire, while current is actual flow of the current itself in a wire. You're explaining current through current. Okay, but necessarily you very close. I understand what you mean. I just wanted to have a perfect explanation. That's it. Voltage is a potential difference, and current is the rate of charge flow. Yeah. Voltage is potential difference. Good. So you guys have said it, but let me explain it in a bit of well animated way. So look, this scenario of a tanker resembles a lot of the voltage and current scenario. So as we put water inside of the tanker, and let's say we pierce the tanker so that we have a hole underneath it, and we keep on rising the tanker. As you keep on rising the tanker, even though you don't open up the knob or the tap here, as you keep on rising the tanker, then you have a bigger and a bigger potential for the water to drop with a higher pressure. If the tanker is at the ground, then there is no potential for it to drop with a higher pressure. But as you keep on rising and rising the tanker, then we have a bigger potential for the water drop. But also inside the tanker, let's say the distance is fixed, what the amount of water that you have pressurizes what's going to flow. Look, for example, inside of this tanker, if I have a smaller amount of water close to the tap or the hole, then necessarily the water is going to drop one after the other, which is almost no pressure. But as you keep on increasing the amount of water inside the tanker, then the water spills extremely with a higher pressure. So the amount of water is the potential for the pressure. Necessarily, it's not the pressure, but it's the potential for the pressure. Exactly with the same scenario, the amount of voltage is the potential for the current. It's not the current or the flow of the current, but necessarily it's the potential that is going to make the current flow. So the amount of current flow, we can resemble it to be the water's pressure flow. As there are a lot of water in the tanker, the pressure is going to increase. Likewise, if the voltage increase, then we have a higher current flowing. So regarding attendance, you have asked a question. So attendance would be sent out randomly during the training. So stay tuned. That's what I can say. The other is resistor. Resistor is a resistance to the flow of current. We said here, current is the flow of electron. So the potential, the voltage that we discussed here, the potential is water. But necessarily when it's voltage, the potential is the amount of electrons. So as we have a lot of electrons and they start to pass through the wire, as the amount of electron increase, there is a high potential and a high flow of current. Likewise, resistance is the way that it resists the flow of current. You see this cowboy. So this cowboy, what he's trying to do is trying to tie up this green boy not to pass through this tunnel. And the voltage is pushing harder and harder to push the green boy. So you see the voltage is the potential. As the voltage gets stronger, then it has a power to push it through. And the resistance would be the one that's holding it back. So this is the concept that you need to know, as it's very important for all the projects that we're going to do. The other thing is parallel and series circuits. So parallel circuits are circuits that you see here, while series are the ones you see here. So in series circuits, the positive and negative signal, or the two signals of the devices, are not actually connected. For example, look here, this is a parallel one. We have two terminals, and the two terminals of the two devices are connected, which makes them parallel towards themselves, and also parallel to the battery because it's connected to the positive and negative exactly the same way. But as you see in series circuits, it's connected to one terminal of the battery, and it keeps on going until the last device comes back to connect to the other terminal of the battery. So in series circuits, current resembles to be the same inside the series circuit, while voltage is divided between them. So from this battery, couple of voltage would be dropped here and another voltage would be dropped here. So they divide the voltage based on the amount of their resistance. But for parallel circuits, they don't divide voltage. They have equal voltage through all the parallel devices, but they divide the current. So it's actually quite reversed. So voltage is the same for parallel components, and current is the same for series components. So discrete component and IC, I've tried to explain it a bit earlier. So discrete components are components that you see like transistors, capacitors, LED, resistors, and everything else. But IC is something inside of it, there is a printed circuit board, something like a printed circuit board. There are a couple of transistors, resistors, capacitors inside of it, and it have a specific function. Inside of this device, maybe there could be 100 transistors. But when it's a discrete component, we have each of the different components. So the other is digital versus analog, which is very important also for any of your project development and as we also progress. So analog does have a continuous values along throughout the data. Like there is 0, and then we have 0 0.01, 0 0.001, 0 0.00001. There is all the values that you think of are there. For example, look at this analog watch. So necessarily it's pointing out above 9 and below 10. You couldn't find a specific point, but necessarily it points out every single point between 9 and 10 as it moves on. But you try to approximate it to a value that's very close. For example, this minute hand is pointing somewhere near 42 minutes. I'm just guessing, but it could be 42.001 or 42.0000001. So this is what we call analog. And analog devices does have all the data that comes along with it. But when it's digital, it's specific and pinpointed value. For example, this is 6 and 11 minutes. So if you have questions about analog and digital, we can discuss more about this. Okay, so you need also to check the rating so that you don't waste your money burning your electronics components. So if it says, like, for example, this is 105 degrees centigrade and 400 volts. If you give it 500 volts, then you're going to burn it out. So make sure that you know the ratings of the device that you use so that you don't end up burning and buying. The same is true for Arduino. I'm going to teach you tomorrow because I saw like 3-4 of you said I have Arduino. I'm going to show you how to use it so that you don't burn your Arduino. Okay, let's all go to tinkercad.com so that we set up our account. And tomorrow, today also maybe I'm going to show you one example, and tomorrow we're going to start doing projects. So for you to keep in mind, these specific training does not include the programming training. So we're going to provide you with the code for most of the circuits. Of course, I'm going to explain the code, but we won't dive in deeper for the coding. There are other trainings, or maybe you can also subscribe to our paid training so that you can learn, including the coding. But also, there are videos that we have in our YouTube channel regarding coding that you can learn. Yeah. I mean, if you know any other programming language, this language wouldn't be any difficult. You can go ahead and learn in our YouTube channel. There is a full course on Python programming. You can learn that. You can ask throughout the process of the training about specific codes, then we can always explain. But I won't be teaching the whole coding journey. All right. So let's all go to tinkercad.com and start creating an account. Some of you have been asking me, what's the class code? Okay, I'm going to send you the class code. So I'm going to create a class. So for those of you who haven't created an account, let me just show you how it's done. So go to tinkercad.com. So make sure that you create an account. Don't just log in as a student. It's going to ask you for a secret code, which is going to be difficult for me to send you out at the moment. Maybe I can create your names for tomorrow, but for now, we are not able to do this. So just create an account, and then after that, you can go ahead and find a way that you can join a class. So you go ahead and say sign up, student, or join a class, and then you go back, then you have something that comes as a student account. So you go ahead and create a student account, and then you can either sign up using your Google or other Gmail email subscription email addresses. So you go ahead and create that. After you create that, then you can join the class as I'm going to show you. So please go ahead and create your Tinkercad account. So anything that you can do on Arduino, you can also be able to do it here on Tinkercad. It's such a nice platform for anyone who doesn't have Arduino. Okay, so once you have logged in, let me go ahead and create a new class. The class name, embedded programming with Arduino. Not required. Okay, I'm going to select anyone who would like to learn could join this class. Oh, okay. Okay, so you can go ahead and start filling in this number in the join class. So if you're looking to find join class, let me show you. Let me not to lose this. I'm going to go into my Tinkercad. So you see here your profile section. In your profile section, you go to my classes. Okay, so on my classes, you go ahead and enrolled, you press on enrolled, and then you go ahead and join class, and you put this number here. But also I'm going to send you a link. You can just click on the link and life is easy. But you need to create the student account first. If you have a Gmail, it shouldn't be difficult. There you go. I have sent you the class link both in the chat section and also in the Telegram group. So you can join the Telegram group. You can join the Tinkercad class. How many of you have actually joined the class? I would like to know. I don't know if it shows me. Let me take a screenshot of this so that you can always use this. Also, let me send you the code if you're looking to join using the code. This is the class code. Okay, let me also send out the screen. I'm sending also the picture of it so that you can join the class. So this shouldn't be very difficult, huh? So once you've joined the class, let me go back to my class. Where do I see my students? Yeah. No, this is from other. Yeah, I think I see you. Rafik, Ayub, this is, yeah, I think this is you guys. I think this is you guys. Someone who've started working are the ones that I can see of their design activities. Students, yeah, these are the students. I can see you guys. But not a lot of you. Please make sure that you create this. So for any of the works that I do, you can always find it inside of activities. You can see activities, right? So inside of activities, you can find what I've done. So you can always go back and refer, you can copy the code plus the circuit and everything else. Okay, so let's send out the attendance. So here is the attendance for today. I'm going to show you one example code where we're going to blink LED using Arduino. As I show you, please go ahead and fill in the attendance. The attendance has been sent out in the Telegram group and also in the chat section. Okay, so I'm going to create new activity. I'm going to say it LED blink. Project 1. We're going to do at least 5 or 6 projects before the end of this section. So I'm going to create the activity. Okay. So this activity is going to be, I'm going to say create design, and I'm looking for circuits. You can also do 3D designs and code blocks, but now I'm looking for circuits. So I'm going to say circuit. You do the same also for your case. Please make sure to revisit this video from our YouTube for tomorrow so that we don't fall behind, okay? So there are a couple of important places that you need to know when it comes to this. By the way, you can learn from your phone also. If you don't have a computer, you can just create a Tinkercad account and that's possible. Maybe tablets, phone, and anything else. So here I'm going to search anything that I like to. So I'm going to say inside of components, all components, so that it brings me all the components when I search. So I'm going to search Uno, Arduino Uno. So you can see that Arduino Uno appears. So I just click on it once and it appears. And wherever I want to drop it, I click another time. Then I give the name that I like here. I'm going to say it Uno. And then for you to minimize the screen, all you have to do is use the scroll bar or maybe the mouse button, expand and collapse as you do it for zooming images in a smartphone. And I'm going to add also resistor. So I'm going to bring in resistor. Okay, so there you go, resistor. And I'm going to also bring in LED. There you go, LED. Now I'm going to do a blinking circuit. As we go on, make sure that you fill in your attendance. Attendance is a mandatory part of the training that we're going to track. You've been taking part in, you've been taking the training seriously so that you're valid for certification. So please go ahead and fill out the attendance for today also. So we use resistor so that all the current that comes in does not burn out the LED. So in LEDs, there are 2 legs. One is the shorter leg, the other is the longer leg. The longer leg is known as the anode, while the shorter leg is the cathode. Cathode meaning negative and anode meaning positive. I don't really know which language it is, but I think it's Latin. Okay, so for the anode, we connect it to the resistor. If you would like to spin your device, all you have to do is at the top here, there is a spin button, which you can be able to spin it, okay? Select any component that you like and you start to spin it. So I connect it here and make it perpendicular. And then for the Arduino, I'm going to explain this in more detail tomorrow, no, don't worry. But the numbers that you see, 0 to 13, are digital pins. These all are digital pins. D1 until D0 until D13 are digital pins. And the ones that has, some wiggly sign are the pulse width modulation. Possibly they can be used for pulse width modulation, which we're going to discuss in one of the classes. And this is a ground, ground meaning negative. And on the other side, this is the analog pin. So I have explained the difference between analog and digital, but we can revisit this if you don't really understand, because it's quite vital you need for you to understand digital and analog. And this is a 3.3 volt output, this is a 5 volt output, this is also a ground, and this is a Vin if you'd like to inject voltage that passes through the board, not through the IC. So this is the IC in the Arduino. So one thing to mention regarding Arduino is that Arduino made life so easy because you don't program the IC directly, which was very difficult for you know, anyone who would like to be a maker. But putting it on the Arduino board now, it's quite easy. You don't have to do, you know, memorize the memories and everything for programming. You don't have to be an engineer to do IC programming. That's what it means. Okay, now let's connect the cathode to the ground. Let's connect the cathode to the ground. And if you'd like to change the color, that's very good. You see that the color drop down menu here, and usually cathodes are black. So keep in mind to put the color codes. Black is for negative or cathode, and positives are usually red. But you can use any other color that you like for a signal. So I'm going to give it in one of the digital pins that I like. Okay, now that you have connected it, there's a place where it says code. So you press on that, and then you can select between which type of code that you like. Is it a block plus text, or text? It's, I think, much easier to use text for now, so we're going to use text. So in Arduino codes, I'm going to explain more tomorrow about the coding, but necessarily this is the setup where once you set up all the digital pins and everything, or analog pins, input, output, and everything else. And this is the actual code that runs again and again as long as the Arduino is powered on. For now, I'm going to put the pin that is connected. So we have connected digital pin 4. So I'm going to write the code here to be digital pin 4. And it's an output. So digital write, it writes on digital pin 4 as high meaning on or 5 volt, previously as I've explained. And then there is a delay, which means it's going to stop the program at whatever previously it worked. And then it's going to make digital write, and it's going to write to pin 4 low, which is 0, and then it's going to delay for 1000 milliseconds. So whatever you write inside of the bracket of delay, it's going to be in milliseconds. Okay, once you're done with this, you go ahead and run the simulation. You see now my LED is blinking for 1 second. 1000 milliseconds is 1 second, so it turns on for 1 second, it turns off for another 1 second. This is how it's done. For the code, I'm going to explain it a bit more tomorrow, but for now, I'm going to just send out the code for you in the chat section. And I would like to see what you have done. Please go ahead and do a screenshot and send out in the group. Okay. So you can do this after the class, but now it's exam time. So every class is followed with exams, simple questions. So Dave would be sending out the questions and you would be doing it. So the exam is going to be for 10 minutes. Make sure that you do it well. So Dave, you can go ahead and send out the exam in the group. I'm going to put a timer for 10 minutes, and then you start to do the exam. Is everyone ready? So for these circuits, you can always revisit it from the activities, okay? It's always there. So you can go ahead and check it out from the activities. Look, I can go to class, and you can go to enrolled and go to your class. For me, it's teaching embedded class, and I can go to activities. You can see that LED Blink Project 1 is here. So you can always revisit it from there. But for now, let's focus on the exam. So I'm going to put a timer for 10 minutes because the exam is in 10 minutes. Dave, whenever you're ready, give me a signal, and then I'm going to put the timer on. So the exam has been sent out in the Telegram group. Can you also put it in the chat section? Okay, when the 10 minutes ends, we're going to close the exam, so make sure that you use your time effectively. Okay, good luck. For those of you who haven't subscribed still, we'd really appreciate you go ahead and subscribe to our channel, and also you share it to any of your friends who'd like to learn a lot of things regarding embedded systems, Python programming, data analytics, website development, and anything regarding technology and STEM education. So we're doing a lot of things, and we start to do this in specific Ethiopian language and African language. We'd start off with Amharic. So if you'd like to have some of the lectures in Amharic, please go ahead and write it in the chat section so we start to do this. Also in the videos, you can write in the videos, I would like this video in Amharic. You can go ahead and say that. Okay, good luck on the exam. Let me not disturb you a lot. Okay, guys, so the time is up for the exam. So please make sure that you revise what you've been learning today. And tomorrow we're going to be starting exactly at 5 p.m. GMT plus 3 Ethiopian time or East African time. So let's meet there tomorrow. So make sure that you revise. Thanks a lot. For anything that you want to revise, please go through the video. You can find it from YouTube. As we close this section, you can always revise it. Yeah, have a good night. See you tomorrow.